Hello friends, I welcome you all in the world of mathematics. I am Atul, your maths faculty. I am going to discuss with you Rolle's theorem. It's very important theorem. First of all, let's see what's the statement of Rolle's theorem. Let fx be a function from closed interval ab to r, and let it be continuous on closed interval ab, differentiable on open interval ab, such that fa is equal to fb, where a and b are some real numbers. It is quite natural. If these conditions are fulfilled, then there exists at least one c in open interval ab such that f dash c is 0. First of all, try to understand. There is a function, there is a real valued function defined on closed interval ab. यहाँ closed interval ab हमारा बहुत बड़ा concern है. Function is defined on closed interval ab. It is a real valued function. On the same closed interval where the function is defined, it is continuous. And on open interval AB, it is differentiable, right? If the value of function at the end point of the closed interval AB, that means at A and B is equal, then there is a real number, at least one real number C in open interval AB where the derivative is 0. It is a quite natural phenomena. We will try to understand it by an example. It will be clear then. Let us take fx, a function fx is equal to fx is equal to sin x. Very simple function. And let the closed interval be 0 to pi. Okay. Let us draw the graph. From 0 to pi, this is the graph of sin x. Right. So just try to understand. Sin x is defined on this open interval 0 to pi. Defined, there is no doubt at all. It is defined. Also, it is real valued function. For all the angles, sine is a real number. So the function is defined on closed interval. So you can say like this. Sine is f is defined from closed interval 0 to pi to r. Right? If fx is sine x, it is defined on closed interval 0 to pi. Fine. Another thing, being trigonometric function, this f is what? Continuous. And it is also clear from the graph. Graph से भी देखिए ये clear है. It is continuous in closed interval 0 to pi. Also the graph is everywhere smooth. At every point you can draw the tangent. Right? So it is differentiable in open interval AB. Open interval not AB, yes, it is 0 to pi. Right? So it is defined in closed interval 0 to pi. It is continuous in closed interval 0 to pi. It is differentiable in open interval 0 to pi. And also f0 is equal to sine 0 is equal to 0. And f pi is equal to sine pi is equal to 0. So you can say that f0 is equal to f pi. Right? So here we can say that all the criteria are fulfilled. f is continuous in closed interval 0 to pi, differentiable in open interval 0 to pi, and f0 is equal to f pi. If we compare with the definition, what is a? A is 0 and b is pi. Now try to just get f dash x. What is f dash x? F dash x is, what is differentiation of sin x? It is cos x. So f dash x is cos x. Fine. F dash x is 0 implies cos x is 0. This implies x is 2n plus 1 into pi by 2. Okay. Odd multiple of pi by 2. Take n0, x is equal to pi by 2. This value of x, that is pi by 2, belongs to open interval 0 to pi. Fine. So we have been able to find out a number pi by 2, which is an open interval 0 to pi, and at this point f dash is 0, f dash pi by 2 is 0. Okay. Where is pi by 2? This point is pi by 2 in the graph, and here you can see that the tangent is parallel to x-axis, right? The tangent is parallel to x-axis. That means the slope of derivative is 0. Okay, so this is a beautiful example to understand Rolle's theorem. We have taken function sin x in closed interval 0 to pi, and we have seen that all the conditions of Rolle's theorem are satisfied, and there is a c, there is a number in the open interval 0 to pi where the derivative is 0. So friends, this is observation. In the nature, there are so many functions which are satisfying conditions of Rolle's theorem, and that's why Rolle's theorem came into existence. थ्योरम कहाँ से आता है? हम प्रॉपर्टीज को, मैथमेटिकल फेनोमेना को ऑब्जर्व करते हैं और वहां से थ्योरम्स बनते हैं. हम उन्हीं जो ऑब्जर्व करते हैं उन्हें जनरलाइज करते हैं, एंड वी गेट अ थ्योरम, राइट? So this way we have understood this by taking a simple example of a trigonometric function. Okay, we can take other examples also, like let's take a very popular algebraic function. Fx is equal to x square plus x plus 1. Okay, and let the closed interval be -1 to 0. It is a polynomial, right? Polynomial is continuous on entire number line and differentiable on entire number line. Polynomial function is continuous and differentiable everywhere in its domain. Fine. So this f is what? Continuous in closed interval -1 to 0. Also differentiable in open interval -1 to 0, and f of -1 is equal to 1 minus 1 plus 1, that is 1, and f of 0 is also equal to 1. So f of -1 is equal to f of 0. Friends, all criteria of Rolle's theorem satisfied here. Fx is continuous in closed interval -1 to 0. It is differentiable in open interval -1 to 0, and f of -1 is equal to f of 1. Now let us get f dash x. F dash x is 2x plus 1. Fine. F dash x is equal to 0 implies x is equal to -1 by 2. and minus 1 by 2 belongs to open interval minus 1, 0. Fine. So this function fx satisfies all the conditions of Rolle's theorem, and we have been able to find the c where derivative is 0. Okay. Minus 1 by 2 is a point where the derivative is 0. F dash of minus 1 by 2 is 0. Okay. Let's try to understand it by the graph. This is x-axis. This is y-axis. Y is equal to x square plus x plus 1 is an upward concave parabola. At 0 it is 1 and at minus 1 it is 1. Okay. At minus 1 by 2 its value is what? 3 by 4. F of minus 1 by 2 is 3 by 4. You can check it. So the graph goes like this. Upward concave parabola. At minus 1 it is 1, at 0 it is 1, and at minus 1 by 2 the tangent is parallel to x-axis. Okay, that means the derivative is 0 at this point. So friends, we have been able to find out one value minus 1 by 2 in open interval minus 1 to 0 where the derivative is 0, and this is a best example of Rolle's theorem. Okay, so we have tried to understand Rolle's theorem with the help of sin x in closed interval 0 to pi and fx is equal to x square plus x plus 1 in closed interval minus 1 to 0. Okay, I think it's quite clear to you. Okay, thank you very much.